Okay, now I know that Mandy sent you some questions that you might want to answer. Do you want to go ahead and introduce yourselves first before we get started answering questions? Dr. Ofoli, I'll let you go first.
Okay, so just some quick background about myself. Born in Ghana, West Africa, with three younger siblings, two brothers and a sister. Okay, Ghana is really hot; it can be very humid, but it's a very, very stable and great country to visit with lots of attraction. Okay. Uh, Finished my BS 1999, got a scholarship, came to the US to do my master's, basically my graduate studies. Finished that 2006. Did some work in the industry after that for 4 years, and then joined UTC in 2010. I think that's a very quick, short summary.
My name is Dr. Don Rising. I'm a professor in the electrical engineering department. I'm from Ohio originally. I did my bachelor's work after 4 years in the Army. After high school, I did my bachelor's studies at the University of Cincinnati in Cincinnati, Ohio. I then worked or was hired out of my bachelor's program by the U.S. Air Force. So I was a government civilian, federal employee working for the U.S. Air Force on Wright-Patterson Air Force Base in Dayton, Ohio. When I was hired, the program I was hired through paid for my master's degree. So I was a full-time employee paying salary, plus they paid my tuition and my books to go to college, to go to grad school full-time. I attended the Air Force Institute of Technology on Wright-Patterson Air Force Base. It is a graduate school only. It was actually created in response to the first airplanes being bought by the U.S. Army following the Wright brothers' first flights. So the U.S. Army at the time realized that no one understood aerospace and flight aircraft principles. So they created a school to teach people that. And some of the first instructors were Wilbur and Orville Wright. And then so I just my job allowed me to continue on with my studies, and I finished my PhD. So basically, between my Army time and the time I worked for the Air Force, federal government paid for my entire my entire education from bachelor's through PhD. And finished my PhD in 2012, and I joined UTC in 2014 within the electrical engineering department.
Very good. So I think the first question that we want to address is, how did you begin to become interested in electrical engineering? Dr.
Mm.
Foley, you want to address that first?
Okay, so I would say in general, we have a lot of students who can become very good at electrical engineering, but really have no idea. And I would say maybe initially I was one of them, right? But I would say that if you have a very strong interest in science, if somehow you are very good at mathematics, right, and enjoys, electricity and magnetism, which we normally all do, or which are normally taught in physics, then you are a very good candidate to become a very good electrical engineer. So some about my background, how I became an electrical engineer. So in our educational system, back home in Ghana, our junior high, senior high is normally known as what we call a junior secondary school and senior secondary school. So if you finish junior high and you get a very good grade, then you get to choose what major, and science is on top. So not everybody gets to go to senior high and decide to do science. So it becomes more like a privilege, something like that. So if you do well in the national exams at junior high and you go to the senior high, then you can choose to do science, or you can choose to do arts or other subjects. But if not, when the science cap is full, then you have to basically choose other. So I basically went through that process. I chose science, and then at senior high, it's also very strange, slightly different from what we have over here. So if you choose science, they basically put you into two categories. You have to either choose to do physics, chemistry, math, which is going to lead you to engineering, right? Or you have to do physics, chemistry, biology, which is going to lead you to the medical field. I mean, my favorite subject when I was both in junior high, senior high was math. So obviously I went to the physics, chemistry, math. Still, I don't know what type of engineering I would do. And then I went through senior high and graduated. Now, when you get to the university, that's when we finish the senior high. Still, we didn't have any introduction to different type of engineering programs when we were in senior high. You just want to get to the university. There is only one university in the whole country, my time, that does a bachelor's of science in engineering. So only one university. So everybody is fighting for that. So you just want to get to the university. When I finished, I realized that electrical engineering was actually the most prestigious and competitive program at the university, right? Followed by mechanical and then civil. The reason maybe we have a lot of jobs in electrical because of the power sector, but that was the most competitive. So most of the time, those who do science, when they do well, they will choose electrical first, mechanical, unless you are interested in mechanical, then you can choose that as your first choice. So that's how I got into electrical. So I said, okay, electrical is most prestigious. Let me just go with electrical. Mechanical second, chemical, and then I got into electrical. So somehow that's how I entered into this field. And like I said, if you have a passion for maths, passion for physics, you love it. And since I entered, I love it. I love it. I love it. So that's my path to electrical engineering.
Thank you for sharing it. It sounds like you had to choose at a very young age what you were going into.
Yes, yeah. They've basically forced you from the science perspective, because when you have to go to the even the junior high, you have to choose whether although everybody does science, right? But senior high, you have to focus. So you have to choose three classes, either in the science, in the arts, right, in the business that you want to focus on, and basically from there on, you are fixed to university. I mean, your path is basically restricted from there on. I like science, I like math, so I think that guided me and straight to electrical. Yeah.
Thank you. How about you, Dr. Rising?
I some of it's very similar with Dr. Foley. So I always did really well in math and science growing up as a kid in school. I always found those subjects very fascinating, very interesting. I liked learning about why things, like in the case of science, why things behave they did, what made things occur the way they did. Math is, for me, I always tell people I'm bilingual. I'm bilingual in English. My first language is English, but my second language is mathematics. And when you can understand the world from a math standpoint and see, I would just play little games in my head with math. I still do. Driving down the road, I'll look at mailbox numbers and I'll multiply the numbers together. I'll add the numbers together. I'll come up with different ways of just playing these little mental games with the math in my head, just for fun. So I'm truly a math geek or nerd in that way. So when I joined the Army after high school, mainly because I did it to pay for college, I needed a way to pay for school. I didn't come from a family with a lot of money. And I was fortunate that the job I did, I was a radio repair technician. So I fixed communications equipment. And I liked that job. I picked that job because I knew I could probably do it as a job once I got out of the service. So I felt it was a marketable skill. Plus, I got to work with technologies. And in doing that, I knew I always wanted to because of my math and science, I always knew I wanted to get into engineering. I didn't know what field. Originally, I was going to get into aerospace engineering. But after working in communications and communications repair in the Army, I decided electrical engineering was where I wanted to be, because I wanted to know why things worked the way they did and how they worked. I didn't want to just fix them. I wanted to know,
Yeah.
I served a deployment in Iraq in 2003, and it's amazing that you could get on a satellite phone halfway around the world and call your family and talk to them, and they recognize your voice, you recognize their voice, and you can have a conversation. So that's the power of electrical engineering, those connections that allowed me to communicate with my family that in wars past was not possible. really fascinates me, and why I'm an electrical engineer, and why my area is even my area of specialty is electrical engineers and communications. That's my
Yeah.
focus within the discipline of electrical engineering, and my research is in that area as well, for those reasons.
Since you're already speaking, Dr. Rising, I'm going to go ahead and ask you another question. What do electrical engineers do? I know there's a lot of options out there. Are they just electricians who know theory? I mean, really, what do they do? That's the question. That is really
my first answer to that is, what don't they do? That's my first response. If anything touches electricity, or uses electrons, it's an electrical engineer can works on it. So I know a lot of people think of electricians in wiring a home. Those are really basic circuits, and they don't require really understanding why things work the way they work or how they work, right? Just a matter of connecting things together. And even electricians take, I can say this because I have an older brother who is an electrician. Even they learn some basic circuit principles, what our students would learn in like circuits 1, and balancing, but they look at it from like balancing circuits and stuff. But when you think of electrical engineers, the difference between an electrical engineer and electrician is an electrician's knowledge stops at the wiring and the connections. The electrical engineer goes far beyond that. You look at the power system, we deal with the generation, the transmission, the instrumentation of the grid, the balancing of those loads. So there's a lot of even from the power side, we as users of the power grid take it for granted. We see it really as a black box outside. Once you plug into the outlet, anything behind the outlet on the wall, we don't think about it, right? We just take it for granted. But there's 100+ years of electrical engineering that make all that work the way it does. When you look at your cell phone, the complexity of those devices, the fact that you can be in a car driving 65, 70 miles an hour down a highway and carry on a phone conversation, or if you're a passenger, watch a video or watch, live stream sports on your cellular phone. That's pretty amazing, right? That's a testament to the technology. That's a testament to the engineering, the electrical engineering that goes behind in the design of those devices and those components that make all that possible. So, in my career, I worked, reason I chose the University of Cincinnati is they created the co-op program. They created the first mandatory internships and co-ops as part of their under their bachelor's programs in engineering. So they required every student to serve as interns or co-ops during their bachelor's program. And I got to work as everything from sales. I worked as a sales engineer. My first co-op job was with Cincinnati Bell Telephone in Cincinnati, Ohio, and where I worked in small businesses. And I was part of the very first voice over IP instantiations of those technologies. Early on in the early 2000s, voice over IP was new and helped solve some really big issues that Cincinnati Bell dealt with in terms of some of the small business solutions that they offered and to some of the customers that they offered. So it caused me to use things like I had to set up a DHCP server. I had to set up, an email server. I had to set up, a voice a phone service inside of a simulated company to sell and pitch to potential customers. And then I also worked as a co-op for a steel company in Middletown, Ohio called AK Steel. I worked in their hot strip mill, where they would take a 70-ton slab steel, 70 tons, just to give you a perspective. The Abrams tank in the U.S. Army weighs 70 tons. So we would take a 70-ton slab of steel that's about 4 to 6 inches thick and mill that down to a coil of steel that was roughly between 1/2 and 3/4 of an inch thick. And we would do both regular standard stainless steel and regular standard steel as well. And I always thought that was cool. Every week when I worked that job, they had a walking platform that ran the full length of the mill. I would start at the reheat furnaces. We had 4 of them in that place. And I would pick a slab coming out of the reheat furnace and walk it through the finishing mill, or the roughing mill, the finishing mill, and then finally the coiler. And when that steel was coming out of the last stand of the finishing mill, it was going about 35 miles an hour going into the coiler to make the coil of steel. So when you see these trucks driving around with coils of steel on the back, that's where that's coming from. And I was responsible. I was a controls engineer. So my first job, my first task that I had when it's a new co-op was to go out in one of the reheat furnaces was having issues where it was scarring the steel coming out. They have these lifters that go in, they just look like fingers, and they call them fingers actually, that go into the reheat furnace, and they lift the hot steel up, slab steel out, and they pull it onto the roll line. And when it was doing it, it was still traveling forward as it was lifting, so it was gouging the steel. And see, one of the issues, is about quality, maintaining a high quality product, and you can't have the process inflicting, degrading your quality. So my job was to figure out a way of solving that, finding a solution to mitigate that problem. So I developed a set of control processes and then implemented them to basically solve that problem, which I did. And I found it really cool. The whole job was really cool. I mean, learning about how they regulated the furnace temperatures, how they kept them constant using controls and thermocouples, how a thermocouple works. I mean, come on, it's using basic principles of physics between two dissimilar metals to generate a current that's measured and indicates how much temperature is proportional to the temperature. So it's really cool. And I learned a lot. I learned a lot in that job. And I got stuck in on a lot of different topics, but and then after I graduated, of course, working for the Air Force and did a lot of different jobs with them. Started off as a communications navigations engineer, working in avionics systems, so integrating those particular devices inside avionics of different aircraft. Hold on a second. Sorry, homeschooling. Sorry. Kids don't care. They don't care what I'm doing. It's all about what they want to do. And so he's telling me when he has to be back in class. But yeah, so I just did a wide variety of stuff in those areas. So you can see in some of that electrical engineers, there's really, like I said, there's no limits to what you can do.
Dr. Ofoli, I was wondering if you could tell us of a time, and I know that you worked very hard from the time that you were very young, but was there ever a time that you had a failure or something that made you doubt yourself and doubt that your path into electrical engineering was not correct?
Wow, that's a interesting question. So yeah, I would say we all of us have setbacks in life, right? Now most of the times this might be due to things which are beyond our control. And I would say that we should not let these setbacks or failures, decide what our future is going to be, right? It's always good to follow your passion, but there has to be hard work. So there has to be hard work. You have to have patience. You have to persevere in what you think you really want to do, and you can always make that dream come true. Okay. So I would say maybe when I was in college was very rough, right? College was very rough back home in Ghana. A couple of setbacks, personal and also maybe at the institutional level, where we have to, there was 1 year, the whole university was shut down due to student protests, and basically everybody was sent home. The university basically was closed for almost a whole year, so basically I have to spend 5 years instead of 4 years, but 1 year was just basically sitting at home. So that was a big setback, but we came back strong and finished it. I've had classes which have really struggled in electrical engineering, even with my background in maths. So some concepts can be very abstract. So you have to be able to grasp what the concept tells you. But like I said, sometimes after perseverance, you don't just give up. not all the classes are going to be perfect for you, right? So just like all our fingers are not the same, right? You are going to love some of the classes in electrical. Some of the classes you are just going to be okay, average, and that's okay. You don't need to get A's in all your classes, so that shouldn't discourage you. So yes, I've had really tough days, tough classes during my undergrad year, but we finally made it, right? Uh, so that was during that time. As when I started to work, maybe when I started as a professor here, some of the setbacks I would say, sometimes you put in a lot of work, research work. I'm very hands-on person, so some of my experiences when I was at Cummins, I was hands-on. So I worked there for 4 years, right? I was designing systems for the engines, right? Just to make sure that the emissions which comes out of the cars that we all drive is safe, right? So it's a job I really love because it's good to the environment, right? To make sure everyone, all of us have cars. So I work on that technology, and it's basically designing, going to the tech cell, testing, and then also going on the road to make sure that your design, your technology is working. So it's very fun, right? You do your software on your computer, you put it on the hardware, you go to the lab, and then you put it in the car to make sure that whatever you design is really working. So that was a very fun time at the at Cummins. Then when I moved to UTC, basically, now I have the mandate to teach very young and brilliant students, right, and to train them in electrical engineering. I start to coach young students, middle school, high school, in robotics, in terms of their teams and programs. I take them to competitions just to get them excited in science and electrical engineering. That also comes with a lot of challenge, a lot of setbacks. Sometimes you feel like, okay, next year I'm done. I'm done. I'm quitting this, But then year after year, you jump on it again. So there can be a lot of setbacks, but like I said, patience and perseverance. What I was talking about being a professor, you do a lot of research work. You put in a lot of work in the lab. You submit a paper for a journal, and then it comes back and they said, okay, no, this journal is not accepted. So sometimes it can be really hard, but what do you do? I mean, you have to step back. These are your peers, these are your own colleagues. You have to recoup back your energy, look at their feedback, and hopefully that is going to help you to even get a better paper the next time you submit it. So yeah, you can have setback in those also, even for us as professors in this field. Yeah, sometimes you can have some setbacks, but that shouldn't keep you back, right? That should give you the energy to actually move forward in your career. Yeah. Don, maybe you want to add some stuff.
Yeah. So my third year of school, so Cincinnati's a 5-year program for their bachelor's degree. In my third year, I took my first electronics course after basically doing circuits 1 and circuits 2. Took the first test and I bombed it, straight up F, solid. Just that was a course where, I think the first part of that was learning op amp theory. And I just, like, for me at that time, op amps were just, I couldn't wrap my head around it at the time. And got my exam back and was walking home after class and thinking, man, maybe I'm just not cut out to be an electrical engineer. Maybe it's just not my thing. But I went and talked to the professor. I went and sought out the professor of the course, and I said, I really need your insight and your help. What should I drop this course? What should I do? And can I still salvage my grade? I don't want to drop the course. I don't want to quit. That was a personal decision by me. I had thought about how much work it had taken me and sacrifice it had taken to get me to where I was. I'd served 4 years in the Army. I was an older, college student compared to a lot of other students. And he told me, he's like, no, don't give up. This is one test. You still have 3 others. He goes, I typically do extra credit assignments with part of the homework. He goes, you're doing the homework. He goes, take advantage of my office hours and ask questions. And I did all those things. I studied really hard. I worked with the professor. I met with study groups. I had peers that I formed study groups with and started studying with the students who really were understanding things in the course. And I studied really hard. And I think I ended up with a C plus in that class. And I look back at that class that I got a C plus in, and I felt that I learned more earning that C plus than all the classes I earned A's in.
Yeah.
So, you know, failure is a lesson in and of itself, right? Um, I always tell students who make mistakes or do something wrong, it's not about the mistake; it's what you learn from it. And the same with failure. You know, it's not about the outcome; it's what you learn from it and
Yeah.
how you take that and go forward. Right? It doesn't have to define who you are. We all face failures. We all make mistakes. We all make bad choices at points in our lives. I still do at times. That's part of being human, right?
Yeah.
But the benefit is that you're learning. The one thing I always want students to understand, that you're an academic environment. It's about learning. Don't be afraid
Mhm.
to learn. And like I said, that C plus, I learned more for that C plus than I did a lot of A's, the courses I got A's in. So because it drove me to really focus on something and understand it and make the effort I needed to do. So that was what I learned, that if I really put my mind to something, I really study and work, I can figure it out. And I seek and leverage everything that's available to me, all my resources. That's the professor, that's my peers, that's the text, the notes, all that stuff. Then I could do it. I could be successful. And that was a pivotal point for me in my undergraduate studies, and served me well the rest of the time I was in school.
Thank you for sharing that. I see a lot of head nods in the class, so I feel like a lot of us understand where you're coming from.
Yeah.
In the
It's a,
interest of time, I was just hoping real quick you could share with us some words of wisdom. What what do you wish that you would have known earlier in your quest to become an electrical engineer or in your career?
I will just say something quickly here, also as an advice that it's really never too late to chase your dream, right? Especially when it comes to education, it's never too late. And in this time that we are in, where things are more flexible, you have a lot of opportunities and different ways to get education. One example I want to give over here is one of our own EE graduates here. We had this international students. She came in. She already had a master's degree, but this master's degree was in mathematics, right? And somebody mentioned or suggested for her to enroll as an EE. So something she didn't want to do. She wasn't very sure. So she came. She talked me. She talked to Dr. Ayrton, and then finally, initially she hesitated because like she's done a BS, she's done a master's in maths, and now she has to go back to school and do an undergrad degree again. She hesitated, but finally she ended up being one of our best graduating seniors, right? She got a full-time job. She's currently working in Chattanooga here. Once in a while I meet her, and she's very thankful. So she's very thankful and satisfied she made that decision. So I would say it's never too late. Whether you have a degree already, whether you've started a program already, it's never too late to chase your passion, especially if it's something that you like. Okay, Don?
Two things. One, study groups. Your peers can explain things a lot of times in ways that are better than the professor can. They just are, because they're kind of in the crucible with you, right? They're going
Mm-hmm.
through the trials and tribulations of that course with you. So study groups, forming study groups, are good for helping you learn, but also they're good social, right? Social interactions.
Yeah.
The other one is, and I always tell my students this: hold your professors accountable, right? We're here to do a job. We're here to teach you and to share what we've learned and what we know with you.
Mm-hmm.
So if you come to us and ask a question and we answer and it doesn't make any sense, it just doesn't answer your question, be persistent. Don't let a professor offer easy. Hold them to it and say, I still don't understand, Dr. Jones or Dr. Rising or Dr. Foley. Um, because, you know, the one thing I want people to realize is an education is for you. It's yours. No one can take it from you. No one can deprive you of it, right? So what you put in is what you're going to get out. And if you hold your professors accountable, I don't know of one of us who came to this job because we hated answering questions from students. You don't become professor for that reason.
Yeah.
I think it's the most rewarding job because I get to interact with students,
Yeah.
because I get to see and get to be a small part in students learning something and understanding something and seeing that light bulb moment on their face when I explain something or teach them something they didn't understand before or didn't know before. So yeah, just be persistent and don't be afraid to challenge your professors and ask them a lot of questions. Uh, that's really the two pieces of advice that I would share with you all.
Thank you so much to both of you for being with us today. We really appreciate it. And as my students are getting ready to present their final projects in the classroom, I feel like they got some words of wisdom from you, and I feel like we're going to send them off into the spring semester doing well. So thank you so much for
That's good.
that, and y'all
Yes.
have a good day.
Thank you for
Thank
having
you.
me.
Yeah, thank you for having us here.